Hello students, we have completed chapter 1 of electrostatics, that is electric charges and fields, and in that chapter we have seen the two properties of the charges, that is electrostatic force and electric field. Next chapter of first unit electrostatics is chapter 2, that is electrostatic potential and capacitance, and these are also the properties of the charges. Electrostatic potential is one of the property of the charge, and the capacitance is the property of the conductors or charges, we can say. And first we'll start with the electrostatic potential in this chapter. Electrostatic potential. First, let me define what is electrostatic potential difference. Electric field is what? In the last chapter we have discussed electric field is what? This is just the space around the charge in which its influence can be felt. And potential is what? How much influence can be felt, how strong the charge is. Suppose there is one charge and you want to place another charge in the field of the first charge, then obviously you have to do some work against the force of attraction or repulsion to place that charge in the position in the electric field of the first charge. So how much work you are going to do in order to place another charge in the field of the first charge. So that amount of the work done by you will decide what the charge is having the potential, how much potential that charge is having. So potential is what? So this is before defining potential at a particular point, let me define what is potential difference. For example, I am having this charge, suppose plus Q is the charge. Now around this some electric field is there, and we know that the range of the electric field is infinity. So I'm going to consider 2 points here. Let us consider one point is here and one point is here. Now let us consider if this is point A and this is point B, it is having some potential here. This charge is having some potential here. This charge is having some potential here. How we can define the potential difference? Potential difference is what? Means between these 2 points you want to find out the potential difference. So what you have to do? You have to find out the work done in bringing a test charge from one point to other point. How much work we are going to do. So that will give you the potential difference, and that test charge must have the unit value. For example, if Q0 is the test charge which we are bringing from point B to point A. Let us consider we are bringing it from here to here, and now you see, if this is also a positive test charge, this positive source charge is going to repel this test charge. So if you want to bring this test charge from B to A, you have to do the work against the force of repulsion of this particular source charge. So how much work you are going to do in bringing the charge from one point to the other point, that will give you the potential difference. So potential difference VA minus VB is what? This is the work done in bringing the charge from B to A divided by per unit test charge. So means we are bringing the unit test charge from point B to point A. So that will give you how much the potential difference is there between the 2 points. So this particular equation is giving us the potential difference. Now point B2, this is the final position VA, initial potential VB, and work is done from this point to this point. And you can see here, when the charge is here, lesser amount of force would be there, and when the charge is reaching here, more amount of the force would be here. So you can see here the potential is going to get increased. So you have to do the work against the force of repulsion of this test charge. So this particular definition gives you the potential difference between the 2 points. Now, potential at a particular point, how we can define? Now you see, if out of these two potentials, if one we can choose to be 0, and in NCERT also, and it is always convenient to choose zero potential at infinity. So we can consider this, that potential is equal to 0 at infinity. So then you can define the potential at one point. So how we can define potential at one point? Similarly, on similar lines, if you are bringing this test charge from zero potential to a point inside the field of this test charge, then what amount of work is done? That amount of work done per unit test charge you are bringing from infinity to that point will give you the potential at that point. So let us define potential at a point. Potential at one point. So in that case, we will have to bring the charge from infinity. That is also a potential difference between the 2 points, and here one point being at infinity. So electrostatic potential of a charge at a point. Now at one point, let us define how we can define the electrostatic potential. Again, we are going to consider charge. And suppose if I want to find out the potential at this particular point, P. And let us consider this point P is at a distance R from the charge. This is test charge. And this point is at a distance R from the charge. Now, if I want to find out the potential at this particular point, what I have to do? I have to bring a unit test charge from infinity to this particular point. Let us consider infinity is very large distance. Infinity is here. So, we are bringing one unit test charge from infinity to this particular point. And we are bringing the test charge Q0 from infinity to this point. Now, what we want to find out here, in order to find out the electric potential at this point P, we have to find out the work done. So let us define potential first. Potential at point P is equal to work done in bringing the charge from infinity to point P per unit test charge, which we are bringing from infinity to point P. And here obviously we can write or using the same definition, V infinity. So this is the final position. From infinity we are bringing the charge here at point P. So Vp minus V infinity is equal to W from infinity to point P divided by Q0. And V infinity, here we have already defined that potential at infinity is 0. So this equation shows that potential at point P is what? This is the work done in bringing a unit test charge from infinity to point P. So unit test charge, whatever the test charge we are bringing, we are simply dividing the work with the test charge which we are bringing from infinity to point P. So how we can define this? Let us write down the definition of electrostatic potential at a point is defined as the amount of work done in bringing the unit test charge from infinity to that point. So this gives you the definition of the electrostatic potential at one point. So, and one very important thing here is this charge we have to bring without any acceleration. If you're bringing this charge without any acceleration, it means the net force on this charge has to be 0. When you are bringing this charge in this direction, you have to apply some external force in this direction, and that external force must be equal to the electrostatic force of repulsion on this charge due to this charge. We know that both of the charges, positive test charge we are taking here. This is positive, this is positive. So this test charge is repelling that, this source charge is repelling that test charge away from it. So this is the direction of the electrostatic force. So we are applying the force in a direction opposite to the electrostatic force on the test charge. So in order to find out the work done, external force we have to apply, and by applying that force, how much work we are doing. And one more thing, as we have to keep net force on this Q 0. So external force has to be equal to the electrostatic force. So using this concept, we can find out the electrostatic potential. Let us find out the expression of the electrostatic potential at a point. So electrostatic potential we are going to find out. Let us find out the expression for that. So electrostatic potential at a point. So using the concept electrostatic, let us consider a small displacement of the test charge dr dash. So small work done for that small displacement would be E external dot dr dash. Now you see, if external is equal and opposite to the electrostatic force dr dash, now this can be written as minus Fe dr dash cos of which angle we have to see here. You see, this is what this is basically F external. F external is equal and opposite. So if external is this is what this is equal and opposite to Fe. So this is F external is minus Fe. So you can see minus Fe and dr displacement of the charged particle is in the same direction. So we can say 0-degree angle here. So total work done, let us try to find out. So that would be the integration of this minus Fe dr dash. Fe is what? That is electrostatic force between two charges. So we can write minus K Q naught over R dash square. Integration is from infinity to R. We are bringing the charge from infinity to point R and into dr dash. So this can be written as minus K Q naught integration of infinity to R 1 by R dash square dr dash. So let's do this side. So this total work done can be calculated minus K Q naught. Integration of that expression is 1 over R dash with negative sign infinity to R. And minus is going to get cancelled with this. So this can be written as K Q naught 1 over R minus 1 over infinity. And 1 over infinity is 0. So this can be written as K Q naught over R. So this is what, this is the work done in bringing the test charge from infinity to point P. Now as per the definition of electrostatic potential, what is electrostatic potential? That is the work done in bringing the unit test charge from infinity to that point. So in order to find this expression for the unit test charge, we can divide this work done with the test charge itself. So potential at point P is what? This is the work done in bringing the test charge from infinity to point P divided by the test charge. So we are going to divide this with the test charge. So this will become K Q over R. So Q naught will be cancelled. So this is the expression of the potential of a charge at one point. K is what? K is for vacuum. We know that K value of K is 1 over 4 pi epsilon naught Q over R. So you can see here this electrostatic potential of a charge at a point is dependent upon R. It is inversely proportional to R. So we can write electrostatic potential at a point is inversely proportional to the distance of point of observation. As you are going away and away from the charge, this potential will keep on decreasing. But very important thing, potential is a scalar quantity. It is a scalar quantity, and because this is a scalar quantity, so you have to consider the sign of the charge here as it is. If the charge is positive, potential would be positive, and if the charge is negative, potential would be negative. So depending upon whether the potential, as you are going away from the positive charge, then potential will keep on decreasing. And if you are coming towards a positive charge, potential will increase because the positive value is going to get increased. And for negative charge, this would become reverse. If you are going away from the negative charge, potential will be increased. And if you are going towards a negative charge, potential would be decreased, because negative would become more and more. So more negative means lesser value. Scalar quantity, because it is a scalar quantity, so you have to consider the sign of the charge also. And what are the units of the potential? One more thing. Units of potential, volt. And as per this particular definition of the potential, this is work done per unit test charge. So sometimes that is joule per coulomb. So these are the units of the potential. So this is all about the potential at a point. Thank you.